with clear targets, and around these roadmaps there are a lot of research is going on. And you see there is quite a big potential in lowering the CO2 in clinker and also in cement. I don't know, is it my computer? And also in carbonation, but today I will focus on construction sites with concrete, and yesterday evening we spoke a lot that the rest of our emissions have to be tackled by carbon capture. Whatever we do afterwards with the CO2, you see it's nearly 50%. Let's start with the topic Müllgrundgasse, heat waves, and this is a picture of the situation 2036 to 2065 in Austria. Heat waves are getting more, and heat waves are getting more intense. And what you see, and what is, I think, pretty interesting or shocking, is that you see nothing, is, I don't know what's, maybe here, a cable has always two sides. What you see, violet are the zones where we are going to get a problem. And you see, it's not only the city of Vienna, it's also the parts, the valleys in the Alps where we start to get a problem. I have a problem here. Second, we saw this picture today. This is a picture from the last World Economic Forum. If the world reacts like this, we make it worse. Second introduction, 38% of the CO2 emissions, of the total CO2 emissions, are in the relation of buildings. And you all know, also I would say 1/3 of the transport, of the mobility, is also connected to buildings. So it's true what newspapers are writing, 50% or even more is connected to our building stock. But it's not only the material, let me say, you see that 28% is heating and cooling of building. And why I'm showing this is, when we want to build a very good house, we have to have this picture in mind. We are not the builders only, then we have to look at the whole pictures. So at the whole picture and at the whole life cycle. So the idea 15 years ago when we started this ReConstruct project was, we have first bring down the energy demand in the building as much as possible. So efficiency first, good envelope and everything. And second, the rest of energy we need to heat and cool the buildings should be 100% renewable. And you all know the sun is not always shining, a day like today, and also the wind. And so it was clear for us, when we have a good building envelope, good isolation, why can't we use the massive building parts like this column or better the ceiling to store the energy when there is no wind and no sun? This was the concept. And why is it possible? And then we said we want to have a cheap system. Cheap means one system, one part of the building for heating, cooling and storing. Not 56 system and fan coils and that and that and that. This is expensive, and our target was the normal people living in the social houses, the mass of people. How can we decarbonize the surrounding for the mass of the people, not for the villas and the billionaires? And what you see, the principle why we can heat the room, like in this room from the ceiling, is we are heating with radiant heat, with radiant waves. And it is the reason why it's radiant heat and no turbulence, no convective heating, and you have this underfloor heat, these radiators we had the last 100 years, is that the temperature of the surface is only 1 to 3 degrees higher than the temperature in the room. Even on the coldest winter days, it's probably 2 degrees Kelvin, not more than that. And then the heat transfer goes via radiant heat. But what is the problem? The problem is that a wind profile of a wind park looks like this, the blue lines. This is a typical situation for a wind farm in Austria. west wind is going through every week. Let's see, there's bad weather also in Sweden, and we get it from the west. So the wind comes one day, the wind stays one day, and the wind goes away for one day. And then there is probably 4 days, nothing, no wind, probably sun. And so we contacted the wind producer and said, please give us a signal when you want to sell your energy because you have too much. The windmills are turning, the nets are under pressure. And they said, well, we give you an on signal, a 1, when we reach 35% of the maximum power of our wind farm. Then we said, you define it, and they gave us a signal. And I show you what we made with this signal. We said, let's build a very simple house where we put the floors of the underfloor heating simply on the ceilings. There we said we start with a one-family house, 2016, to show the business case. And this was a normal conductor, normal people. And if you're a little attractioneer like me, I love to stay in heating rooms and also on construction sites. It took 3 men 3 hours to make these 80 square meters. And it was the first activated component, concrete core activation in a private home. This was the building, and the heat pump was connected via GSM net to the wind farm 100 kilometers away. And when there was enough wind, the heat pump got the signal, turn on please. So it's not very complicated. In the first year, this is the winter, summers, we could show that we could heat the house with 70% surplus energy, not only green coming from the wind park, it was green and not needed at the time, or it was the situation when the prices go down for the producer of the wind, when he has a real interest that somebody takes out the electricity. You know, I'm a cement guy, and we as cement producers knew this situation since 15 years. 15 years ago, the big energy companies approached us, can you take your big mills with 20 megawatts from the net because we are getting some. So we knew demand side management long before it was in the public, and this was one of the reasons. But the house had some holes because at every window, the guys who built the house said the shading system we make ourselves. And we said, okay, no problem. But what they did was they drilled the passive house wall at every window. They made a hole like this 26 times and put some plastic, wie sagt man, Elektrikerdeckel, on it and painted it. And this was the reason why, and we had a kontrollierte Wohnraumlüftung. We had a ventilation system which is producing an overpressure or underpressure. So it was pulling the cold air via these holes. We didn't know, but we figured it out with a second blower door test. And in the second winter, when the holes were closed, we could show in the first example that we can heat the house with 90% energy from the electricity from the wind parks. So we said, well, city of Vienna, you saw a representative from the city of Vienna, we had a good idea. Let's do it in a social housing, in a big project. And this was the first project, it was Mühlgrundgasse 22, 160 flats, deep drillings, so 3 flats between 50 and 90 or 100 square meters per flat. 3 flats have 1 drilling. So 3 flats need 1 drilling, 150 meters. That's pretty the same here in the building. So this was the first time when we could show with that system, with the drilling, we can also cool the building in summer. In just pumping the water through the concrete ceiling, through the pipes you saw, and then pump it underground, and it comes back cold. And yeah, you see the number. In this building we could show the first time that heating and cooling is below 2 euros per square meter in here. My company has a demonstration flat. We are renting a flat in there, so I have the exact numbers. And yeah, if we would have more time, I could show you that flat. And you see, This is a heat wave running through Vienna. You see it's going up 4 days, 5 days, and then it's reaching 35 degrees. The 35 degrees is not the problem. The problem is the night temperature. The temperature, yeah, you see in the valleys, yeah, it's going up. Also here in this area, it's going up to 23 degrees very often. And then cooling with the window is not that effective anymore. And of course, this our flat is not, there's nobody living in. So it's a flat that is constant, but you saw the flat didn't even react to the heat wave which was going through. And I can show you another example. This year, when the first heat wave was coming to Vienna, it was 19th June, this was a Sunday, or the 18th was a Sunday. I was lying after the lunch, I was tired, I was lying on the sofa, and I said, well, I think it's time to put on the concrete core activation. I can do it from my mobile phone, you know, this ventilation. No, not the ventilation, the ventile. So I said, well, that's now an interesting case. I start the concrete core activation the first time in this year, the passive cooling system. I started 1 day before a heat wave comes. So on Sunday I put it in operation, and then the temperature, as you saw before, went up to 35, 34 degrees. And you see, in 24 or 48 hours, I brought the temperature from 24.75, not too much. I was able to bring it down to 22.5. And now I'll show you my private living room. I have the same system in there. It is not with concrete core activation, and it has a glass facade, and it's of course shadowed. This was the same time my private living room. You see, my family is trying to open the windows the whole night. We are trying to ventilate the building naturally through the building, but we can't avoid, if a real heat wave comes, that my living room goes up to 27 degrees. And now I show you the difference. The one little flat, okay, with small windows, with concrete core activation, that is started right before the heat wave. I think this is not very scientific, but for me it is impressive, because I'm living in the gray one, which means when I go in, when I retire, I will write a book, and the book will be named Living in a Solar Collector. This is another example in...
Can I just...
yeah.
So the passive cooling you did on the...
Yeah.
Was that using the cold water from the heat pumps? Or?
No, the compressor of the heat pump, we bypass the heat pump the whole summer, also in this school building. So there is a heat exchanger, I showed you here in the cellar, a heat exchanger, and then you have one circulation is going to the probe, to the drilling.
Yeah.
Then there is the heat exchanger, and another circulation is going to the concrete ceilings.
Yes, but you call it passive cooling.
Passive cooling, that's it.
Okay.
Only passive. Also this is only passive. The heat pump is not used in the summer, it's only passive cooling. And now as an example, interesting example, interesting numbers. Look at this building. So these 160 flats are in 7 buildings. So in this building, for example, are 25 flats. And these 25 flats have one heat pump in the cellar. The heat pump has 50 kilowatt. And for cooling the whole summer, all the flats, we need 2 pumps. The one that pumps the water underground, and the other pump that pumps the water through the ceiling. So 2 pumps. And especially in this case, this pump has 240 watts each. That means 500 watts is needed to cool 25 flats. That means I have a modem, you know, to have this device in the room, I have a modem there. The modem needs 40 watt, and cooling the flat needs 50 watt. Or divide 500 versus 25. So you see, cooling completely ecological and economical for free. And the good thing is, when we start the winter season, the earth around the drillings is probably 1 degree warmer So it has even a positive effect for regenerating and heating the next winter season. So, yeah, this building I showed you, I come to an end. I'm personally convinced that we are in a luxury situation in Europe or in Vienna, because we still have space and we still have gardens like here, but the mass of the people in the world are living in megacities, and it's going up. 60 to 70% of the people will live in cities like this. I don't know if you know this project from Evergrande. It's this Chinese. This city is called Small Venice. Very nice. Small Venice. But what you see is there is all over these concrete ceilings, and the isolation of these skyscrapers is not enough. And if you have photovoltaic on the roof, like in this school, you would be able to cool 4 or 5 floors, but what you see here are 40 to 50 floors. So how to bring renewable energy for heating and cooling in the other 50 below or in the other 30? And I'm really personally convinced we can bring, the cheapest way to bring renewable energy to these new built megacities is via the electric cable. Because the part where we get the energy will be in offshore wind parks, will be out in the deserts, will be in Africa for Europe, will be in the North Sea, probably for Europe. And you need only electric cable to make then demand side management. And I am convinced these megacities could be a big battery. Of course, we can't cool buildings in Singapore and in the, in the very hot climate. It's not possible because it's only 40 watts per square meter what we are able to comfortably bring in the room. But for many, many places in the world where the climate is similar to ours, it would work. So what are my lessons learned? And architect Zeininger will I think, and architect from Untertriebhaller will show you wonderful examples. We have to learn that cross-sectoral innovation is the future. And whoever does cross-sectoral innovation is running against walls every day, every day. You will see it in the next examples. Cross-sectoral innovation is definitely not wanted. You can imagine I tried 10 years at least of my life to convince construction companies that it doesn't double the price if you put a plastic pipe on your reinforcement. In the meantime, it's the same price. It's the same price as underfloor heating. There's no more price. It costs nothing more than underfloor heating. But in the beginning, everybody tells you heating from above is not possible. Making this to the reinforcement makes, let's explode the cost and so on. Everybody in the room knows what's going on. But you see it works. And once again, here I'm a little, it's written €2 per square meter to cool and heat a flat. My conclusion is we solved the problem. Thank you very much.